Okay, so this question asks to find from 0 to 1/2 1 over square root of 1 minus x squared to the third power. So this question has to integrate. So in this case, if you look at it, it's the form of a squared minus x squared, meaning you have to do x equals sine theta, a sine theta, which in this case our a squared is 1, meaning a will be 1. So x equals 1 sine theta. Okay, and then let's find the derivative of that. The dx would be just cosine theta, d theta. Cool. So, and then you have to find the point. Since x equals sine theta, x equals sine theta, theta would be sine inverse of x. So if this theta equals sine inverse of 0, this is just 0. Theta equals sine inverse of 1/2. This is just pi over 6. So we found the upper integral and the lower integral limit, right? So this is from 0 to pi over 6, and we're gonna substitute dx with cosine theta, so it's gonna be cosine theta d theta over square root of 1 minus x is sine theta, so it's gonna be sine squared theta to the cube power. And if you remember your trig identity, sine squared theta plus cosine squared theta is equal to 1. So cosine squared theta is just same as 1 minus sine squared theta, right? So this can be written as 0 to pi over 6 cosine theta d theta over square root of cosine squared to the third power. Squared and square root can be cancelled out, so this is just 0 to pi over 6 cosine theta d theta over cosine cube theta. And cosine theta can be cancelled out, so this will eventually be 0 to pi over 6 1 over cosine squared theta d theta, right? And this is just same as secant theta d theta, and we know that tangent theta is the integral of secant squared theta. So tangent theta from 0 to pi over 6. So tangent pi over 6 minus tangent 0. Tangent pi over 6 is 1 over square root of 3, and tangent 0 is just 0. So this just becomes 1 over square root of 3, which is D. Okay, so this question has to integrate x cubed plus 3x squared plus 2x plus 1 over x cubed plus x dx. So in this question, if you look at it, the numerator and the denominator both have cubic. So in this case, it's hard to integrate if you just look at it this way. But what we are going to do is we're going to decompose those. So what we're going to do is divide the x cubed plus x value from the x cubed plus 3x squared plus 2x plus 1, which is the numerator. So let's write the numerator, x cubed plus 3x squared plus 2x plus 1, and we're going to divide that value from, divide this value by x cubed plus x. And this will be just 1. X cubed times 1 is just x cubed. So x cubed plus x. And this x cubed will be cancelled out. 3x squared is still remaining. And x 3x squared plus x plus 1 will be the remainder of the function. So this will be just same as 1 plus 3x squared plus x plus 1 over x cubed plus x, entire thing dx. What we're going to do is separate 1 and 3x squared plus x plus 1 over x cubed plus x. We can write this as 1 dx plus 3x squared plus x plus 1 over x cubed plus x dx. 1 dx can be written as just x itself, so meaning it will be just a, b, and f, not c, d, e. So we have that, and what we are going to do for the second part, we are going to do partial fraction decomposition for this case. If you look at the x cubed plus x, this can be decomposed as x squared plus 1, right? So what we're going to do is, let's write this in here, 3x squared plus x plus 1 over x cubed plus x. I'm just going to delete the integration sign for now. and can be decomposed in x and x squared plus 1. So I'm just going to write with x first and then x squared plus 1. Since x, in this case, whenever there's exponent of 1, the numerator exponent will be just 0, meaning it will be just constant. And if there's a squared value in the denominator, the numerator will be just x, meaning it will be just b, x plus c. So if you want to delete the x cubed plus x and x squared plus 1, what we can do is just multiply x cubed plus x in both sides, so we don't have to deal with the denominator. So let's do that. So this will just become 3x squared plus x plus 1 is equal to a x squared plus 1 plus b x plus c times x. I'm just going to rewrite it again because it looks a little weird. So let's just write it again here. 3x squared plus x plus 1. Since x cubed plus 1 x can be delimited by x cubed plus x multiplied, so this will be cancelled out. Is equal to a x squared plus 1 plus bx plus c times x. And what we can do is 3x squared plus x plus 1 will be same as ax squared plus a plus bx squared plus cx. And we can group a plus b in with x squared, and then we can just leave the rest, cx plus a. The same as 3x squared plus x plus 1, meaning a plus b has to be 3, and c has to be 1, and a has to be 1. If a is 1, then b will be just 2, right? So we found all those values for the coefficient and the value. So we know a, b, c values, so we are going to plug it in back. So it can be written as 1 over x plus 2x plus 1 over x squared plus 1 dx. We can separate 1 over x plus 2x plus 1 x squared plus 1, so it can be written as 1 over x dx, plus 2x plus 1 over x squared plus 1 dx. 1 over x dx is just ln absolute value of x. So if you look at the options, they both have it. So sad. Okay. And then we have to do 2x plus 1 over x squared plus 1. Okay. So in that case, what we can do is we can separate 2x plus 1, x squared plus 1 into like 2x over x squared plus 1 plus 1 over x squared plus 1. The reason that we are separating is because if you do the u substitution as like u equals x squared plus 1, du will be 2x dx. But we don't have 1 value, which is why we're separating it right now. So this becomes 2x over x squared plus 1, and we're gonna, as I mentioned before, we're gonna use u substitution for this. I forgot dx in both sides, sorry. So u is equal to x squared plus 1, du is equal to 2x dx, so this just becomes du over u. And then if you remember 1 over x squared plus 1, this is just the derivative of tangent x, inverse tangent x. So this just becomes tangent negative 1, which is just inverse tangent of x. Okay, and if you remember du over u, this is just same as ln u form, right? Plus tangent inverse x plus c. But since u is x squared plus 1, you just plug it in back, ln x squared plus 1 plus tangent inverse x plus c. This is a long question. Sorry, it's a little messy. But if you look at the option, we have ln x, both ln x, and then we have ln x squared plus 1. So meaning it will be a, b, not f. And then it's tangent inverse of x, right? Tangent inverse of x. Oh, sorry. tangent inverse of x, and then plus c, constant, because it's indefinite integral. So the answer for this question is B. Okay, number 3 asks integrate the tangent cube x dx from 0 to pi over 3. Okay, let's write it first. 0 to pi over 3, tangent cube x dx. We can separate tangent cube x as 0 to pi over 3, tangent x times tangent squared x dx, right? If you remember your trig identities, secant squared x is same as 1 plus tangent squared x. So tangent squared x is equal to secant squared x minus 1, right? And we're gonna substitute this value in here. So 0 to pi over 3, tangent x, secant squared x minus 1 dx, and multiply those values, distribute basically, tangent x, secant squared x minus tangent x dx, right? And this entire thing is multiplying dx, right? So in this case, what we're gonna do is we're gonna separate this. So 0 to pi over 3, tangent x secant squared x dx minus 0 to pi over 3, tangent x dx. And if you remember, you can, for this part, you can do u substitution. So what we're gonna do in here, we're gonna do u as u is equal to tangent x, and du is secant squared x dx, right? So this function becomes u du, and we have to find the new interval. So tangent u equals tangent 0, this is just 0, right? U equals tangent pi over 3, this just becomes square root of 3. So it's from 0 to square root of 3, u du, minus this per tangent x. If you remember, tangent x integral is just same as ln, absolute value of secant x from 0 to pi over 3. Okay, let's do the integration now. So u du, so it's going to be u squared over 2 from 0 to square root of 3 minus ln secant pi over 3 minus ln secant 0, right? So this will be just square root of 3 squared, so 3 over 2, and 0 squared is just 0, 3 over 2 minus ln secant pi over 3 plus ln secant 0. ln secant pi over 3 becomes 3 over 2 minus ln 2, and then ln secant 0 is just 1, ln 1 is just 0, so this is just 0, so this is just 3 over 2 minus ln 2. So the answer for this question is B. So this question has to find the correct form of the partial fraction decomposition. So our numerator has x cubed, x to the 5th power plus x cubed, and then x minus 1 squared. In the partial fraction decomposition, you have to first separate the terms. So you can group x cubed plus x to the cube power into x cubed, x squared plus 1, x minus 1 squared. And now after that, you start with the biggest term, meaning x squared plus 1. So let's start with writing x squared plus 1 plus the second next, and then x cubed and x minus 1 squared. If you remember it, x cubed can be written as just x squared, x cubed as a repeating term, and x minus 1 squared can be written as x minus 1, x minus 1 squared. So they are both in the first exponents, so it doesn't really matter on which order you write. So what we're going to do is just write from x, and then write x squared, and then write x cubed. Since it's x cubed, meaning it can be separated into 3 different x, which is why you're writing x squared, x cubed. I don't know how to explain why, the reason behind, but it's just like that's how it works. You just have to kind of remember if it's x cubed or something like multiplied by separate terms or repeating like that, then you just have to repeat it until it reached the maximum exponent. So it will be just same as x minus 1 power plus x minus 1 squared. We have that. So let's look at our options first, whether we can delete anything. So A, we don't have the same format. Also B doesn't have it. C has x squared, x cubed, x squared plus 1, x minus 1, but x plus 1 is not right. X minus 1 squared. So C is not right. D is not right. E is also not right. And F actually follows our general format, but I'm gonna explain it how that numerator works. So if you look at it, it's ax plus b. What is the rule of the general rule of thumb will be subtracting one exponent from the denominator. Meaning if it's x cubed, or meaning if it's x cubed, it will be x squared plus something x plus something constant. So in our case, we have x squared plus 1. So we subtract one exponent. That means it will be just x, but it might have a constant value. So we write ax plus b. And our exponent for this case, the second term is just 1. 1 minus 1 is 0, meaning it's just constant. So it's going to be c. And you might wonder why x squared is b, because it's repeating term. Like if it's like squared or cubed or something more than 1, it's just gonna be following the first term's pattern, meaning it'll be just d and e constant. And x minus 1 is the same logic. Since it's first exponent, it's gonna be just constant value. And it's x minus 1 squared, it's repeating just like x minus 1, so it's gonna be following the same pattern, just having the same constant. Not the same constant, but the same format. The value can be different. So, which is why the answer for this question is F. Okay, this question asks to find from 0 to 1 x squared e to the x to the cube power dx. So in this case, let's write it first. From 0 to 1 x squared e x cube x dx. So in this case, what we're going to do is our favorite friend, u sub. We can put u as equal to x cubed, and we can find the derivative of that, which is 3x squared dx. And we can write 3x squared dx into the form that we want, which is x squared dx, so it's going to be du over 3. So x squared dx can be written as du over 3 e to the u power. And then let's write 0 and 1 into the u format interval. So u equals 0 squared, no, 0 cubed is just 0, right? U equals 1 cubed is just 1, so it's from 0 to 1. Oh, same, cool. And we can take out the 1 over 3 because it's constant. 1 over 3, 0 to 1, e to the u du. So it'll be just 1 over 3 e to the u from 0 to 1. So it's going to be 1 over 3 e minus e 0 value, meaning it will be just 1 over 3 e minus 1. This can be written as just e minus 1 over 3. So the answer for this question is B. Okay, so this question asks to find, to integrate dx over square root of x squared minus 6x plus 10. So for this case, we are gonna write the x squared minus 6x plus 10 into completing the square form. So this can be written as dx over. So what we're gonna do, what you do for generally for completing the square, what you do is divide the coefficient of the x term, meaning divide that value by 2, so x minus 3, and then just write the squared. So it'll be x minus 3 squared, and then you have to add something to make it equal to each other. So x minus squared value is x squared minus 6x plus 9. In order to make this value equal to this entire, so in order to make x squared minus 6x plus 10, you just have to add 1, right? So there you go. We have the completing the squared form of integration. And if you remember your form thing, if it's like x squared plus a squared, this just generally becomes like a tangent, but I will just show you how it works in this case. Just draw the triangle and draw like 1 and x minus 3, and this side will be x minus 3 squared plus 1 by the Pythagorean theorem. So if you, and this is theta, right? So if you want to find tangent theta will be just x minus 3 in this case, and x will be just tangent theta plus 3, right? Okay, and then since we find that, our derivative will be dx is equal to secant theta d theta. Let's rewrite the function now. Dx is secant squared theta d theta, and x minus 3, which is x is tangent theta plus 3, tangent theta plus 3 minus 3 squared plus 1. This can be just written as secant squared theta d theta over 3 and negative 3 cancels out, the tangent squared theta plus 1, and secant squared theta d theta. And if you remember your trig identity, tangent squared theta plus 1 is same as secant squared, so it's gonna be secant squared inside and square root. So it's secant square root and square value we cancel out, so this will be just secant squared theta over secant theta. Secant theta cancels out, so this just becomes secant theta d theta. And if you remember your secant theta d theta form, this is secant theta integration will be just ln ln secant theta plus tangent theta plus some kind of constant c, right? Yeah, that's the form that you have to remember. Like secant theta integration is ln secant theta plus tangent theta. It's just like from your memorization. And now what we have to do is we have to find the secant theta value and then plug it in. So secant theta value, let's find the tangent theta first. Tangent theta is just x minus 3, right? Okay, we have ln something plus x minus 3 plus c. Okay, we have that. And then secant theta, let's find the cosine theta. Cosine theta is 1 over x minus 3 squared plus 1, and secant theta is the inverse of it. I'm sorry, secant theta is just inverse of it, meaning it will be just x minus 3 squared plus 1. So it's gonna be x minus 3 squared plus 1 plus x minus 3 plus c. And if you look at our options, it doesn't have this exact same form as like our answer, but what we can do is we can distribute this part. Ln x squared minus 6x plus 9 plus 1 plus x minus 3 plus c. This is same as ln square root of x squared minus 6x plus 10 plus x minus 3 plus c. So which answer choice has the exact same form, which is D, right? So this answer for this question is D. Okay, so this question has to find the force on the pressure of the throw. Okay, let's start a throw. This is the throw, and this is isosceles looking thing. Even though it doesn't look like it, it's fine. 3 and 5. Okay, and we're just gonna separate this into like a one small triangle, and let's put this as 3, and this entire length is 5, and we're gonna put this water level as L and the water level height as Y, and this entire thing is from 5. So if you want to write L over Y, this would be written as 3 over 5, right? And if you just want to write L, then it will be L is equal to 3 over 5y, right? Which is L is right here, which is this line, the strip line, right? And then what we have to find, the next one is the change of height, which is from entire thing 5, the change of height would be 5 minus y, right? Since we don't know what y value is, but it's changing, it's the remaining height will be just 5 minus y, right? So dy would be just 5 minus y. So if you want to find the pressure, what you have to do is integrate from density, gravity, and volume. And the volume can be written as the Ly times dy. Integrating from P and G, and then L is 3/5y, and then the distance of the water level changing is 5 minus y dy. And it's the entire like height is from 0 to 5, so it's from 0 to 5. Okay, PG is just constant, comes out 0 to 5, 3y minus 3/5y squared dy, right? And this can be written as PG 3y squared over 2 minus 3y squared over 2 minus y cubed over 5 from 0 to 5. This just becomes PG 75 over 2 minus 125 over 5. So this just becomes PG 75 over 2 minus 25. So this just becomes 25 over 2 PGN. So the answer for this question is A. Okay, so this question has to find the force on the pressure of the throw. Okay, let's start a throw. This is the throw, and this is isosceles looking thing, even though it doesn't look like it. It's fine. 3 and 5. Okay, and we're just gonna separate this into like a one small triangle, and let's put this as 3, and this entire length is 5, and we're gonna put this water level as L and the water level height as Y, and this entire thing is from 5. So if you want to write L over Y, this would be written as 3/5, right? And if you just want to write L, then it will be L is equal to 3/5y, right? Which is L is right here, which is this line, the strip line, right? And then what we have to find, the next one is the change of height, which is from entire thing 5, the change of height would be 5 minus y, right? Since we don't know what y value is, but it's changing, it's the remaining height will be just 5 minus y, right? So dy would be just 5 minus y. So if you want to find the pressure, what you have to do is integrate from density, gravity, and volume. And the volume can be written as the Ly times dy. Integrating from P and G, and then L is 3/5y, and then the distance of the water level changing is 5 minus y dy. And it's the entire like height is from 0 to 5, so it's from 0 to 5. Okay, PG is just constant, comes out 0 to 5, 3y minus 3/5y squared dy, right? And this can be written as PG 3y squared over 2 minus 3y squared over 2 minus y cubed over 5 from 0 to 5. This just becomes PG 75 over 2 minus 125 over 5. So this just becomes PG 75 over 2 minus 25. So this just becomes 25 over 2 PGN. So the answer for this question is A. Okay, so this question asks to integrate cosine to the 5/5 power x sine squared x dx. Okay, so let's write it. Cosine 5x sine squared x dx. The rule of thumb, if you see the odd power in the cosine, the u will be just the even power, meaning u will be just sine x. So and du will be cosine x dx. The reason is why is because if you can write this as cosine for x times cosine x and sine squared x dx. Since it has the one odd power, you can write as du, right? Which is why we put u as sine x if you see the odd power in cosine, basically. So let's write it. So cosine to the 4th power x times cosine x dx can be written as du, and u is sine x, so it's going to be u squared. And also, if you remember your trig identity, sine squared x plus cosine squared x is 1. Cosine squared x is 1 minus sine squared x. Cosine to the fourth power is cosine, is basically cosine squared x to the squared, right? Which is same as 1 minus sine squared x squared, right? Okay, so, and since we write sine x as u, this can be written as 1 minus u squared to the squared power. So this thing just basically becomes 1 minus u squared to the u squared power times u squared du, right? Okay, now let's distribute it. Basically, it's gonna be 1 minus 2u squared plus u to the fourth power times u squared du. This just becomes u squared minus 2u to the fourth power plus u to the sixth power du. U to the third power over 3 minus 2u fifth power over 5 plus u to the seventh power over 7 plus c. Okay, and then since u is sine x, let's plug it back. Sine x to the cube power over 3 minus 2 sine x to the fifth power over 5 plus sine x to the seventh power over 7 plus c. So let's find the exact same thing. So for this case, our option will be C. That is the exact same from it, right? So the answer for this question is C. Okay, so this question asks to integrate from 0 to pi over 4 x sine x cosine x. Let's write it first. 0 to pi over 4 x sine x cosine x dx. Okay, if you remember some property, I guess, sine 2x is equal to 2 sine x cosine x, right? And you can write sine x cosine x by just writing sine 2x over 2, right? This is the same thing. Basically move the 2 on the other side. So let's write this in here. Let's rewrite it. 0 to pi over 4 x sine x cosine x can be written as sine 2x over 2 dx. Okay, and in this question we are going to use our favorite friend, integration by parts. So we are going to use Layet form. Layet, log, inverse trig, algebraic, trig, and exponential. And you choose the u in the leftmost order. So in this case, we see algebraic function and we see trig. So we see a and t. Since a comes first, our u will be just x, and du will be dx. db is the rest of the stuff other than x. So it's going to be sine 2x over 2 dx. b becomes, negative cosine 2x over 4. And we use ub minus b du. So u is x, b is negative cosine 2x over 4 minus cosine 2x over 4 dx. Minus minus a positive plus negative x cosine 2x over 4 plus cosine 2x. No, let's just write it. Cosine 2x over 4 integral dx. This is the same as negative x cosine 2x over 4 plus sine 2x over 8, and integrating from 0 to pi over 4. Plug it in. Negative pi over 16 cosine pi over 2 plus sine pi over 2 over 8, and then 0 is just 0 for the negative x, so it's 0, and then sine 0 is also 0, so 0, 0. You don't have to worry about it, so it's just this part, right? So negative pi cosine pi over 2, so cosine pi over 2 says 0, so this cancels out. So sine pi over 2 is just 1. So this thing just becomes 1 over 8. So the answer for this question is F. Okay, so this question has to integrate from 2 to infinity dx over x. So this is the improper integral. So let's write it. 2 to infinity dx over x. So dx over x is basically the form of ln x absolute value, right? And it's integrated from 2 to infinity, right? So it's going to be ln infinity minus ln 2. ln infinity is just infinity, right? Minus ln 2. Infinity minus something small number will be just same as still infinity, right? So this thing is just diverging, so the answer for this question is E. This question has to find the first four terms of the sequence of partial fraction. It's not series, it's the sequence. So okay, this is k equals 1 to infinity negative 1 to k. The first term in our case is 1, so k equals 1. K equals 1 to infinity, negative 1 to 1 is just negative 1. K equals 2 is negative 1 squared, which is 1. And k equals 3, negative 1 to the cube power is negative 1. K to the fourth power is negative 1 to the first power, which is 1. So this is negative 1, 1, negative 1, 1. Right? But it's the first four terms, and then fourth term of the sequence of partial sums. It's partial sums. So it's gonna be negative 1. Negative 1 plus 1 is just 0, right? So it's 0, and 0 plus negative 1 is negative 1, right? Negative 1 plus 1 is 0, so right? So the answer actually wants this one, not the sequence itself. I almost got tricked too. It's asking the sequence of partial sums, not just sequence, which is why the answer for this question is A. Okay, so this question has to find which of the following recurrence relations will generate a sequence with A3 equals negative 3. So the easiest way to find the answer for this question is just plug it in, basically. Just go through each option. A is an plus 1 equals 1 minus 2an, and a1 is 1. A2 would be just 1 minus 2a1, which is 1 minus 2, which is negative 1. A3 is 1 minus 2a2, which is 1 minus 2 negative 1, which is 3, not negative 3, so A is not right. B. an plus 1 is equal to negative an, and a1 is 1. A2 is negative a1, which is negative 1. A3 is negative a2, which is 1, which is not negative 3. Let's look at C. An plus 1 is an plus 1. So a1 is negative 5, a2 would be negative 5 plus 1, negative 4. A3 would be a2 plus 1, meaning negative 4 plus 1, negative 3. So this is our answer, but we're just going to go through every single option. Okay, so D is an plus 1 equals 3an, and a1 is negative 1. A2 would be just 3a1, which is negative 3. A3 would be 3a2, which is 9, which is not our option, which is not what we are looking for. E is an plus 1 is equal to an minus 3, a1 is 0. A2 is a1 minus 3, so it's negative 3. A3 is a2 minus 3, negative 6. So this is not what we are looking for. And the last one. An plus 1 is negative 9 over am. A1 is 3, a2 is negative 9 over a1, which is negative 9 over 3, negative 3. A3 is negative 9 over a2, right? Negative 9 over negative 3 is 3. So F is also not right. So, which is why the answer for this question is C. Okay, so this question has to find the force on the pressure of the throw. Okay, let's start a throw. This is the throw, and this is isosceles looking thing. Even though it doesn't look like it, it's fine. 3 and 5. Okay, and we're just gonna separate this into like a one small triangle, and let's put this as 3, and this entire length is 5. And we're going to put this water level as L and the water level height as Y. And this entire thing is from 5. So if you want to write L over Y, this would be written as 3 over 5, right? And if you just want to write L then it will be L is equal to 0/5y, right? Which is L is right here, which is this line, the strip line, right? And then what we have to find, the next one is the change of height, which is from entire thing 5, the change of height would be 5 minus y, right? Since we don't know what y value is, but it's changing, it's the remaining height will be just 5 minus y, right? So dy would be just 5 minus y. So if you want to find the pressure, what you have to do is integrate from density, gravity, and volume. And the volume can be written as the Ly times dy. Integrating from P and G, and then L is 3/5y, and then the distance of the water level changing is 5 minus y dy. And it's the entire like height is from 0 to 5, so it's from 0 to 5. Okay, PG is just constant, comes out 0 to 5, 3y minus 3/5y squared dy, right? And this can be written as PG 3y squared over 2 minus 3y squared over 2 minus y cubed over 5 from 0 to 5. This just becomes PG 75 over 2 minus 125 over 5. So this just becomes PG 75 over 2 minus 25. So this just becomes 25 over 2 PGN. So the answer for this question is A.